Hello and welcome. Today we are demonstrating the SatTrackerPi. It is a satellite tracking system based on the Raspberry Pi and written in Python. It will allow you to precisely control the alignment of an antenna or telescope or camera so that you can find and track celestial objects. We begin by looking at the gPredict main navigation page, which shows a selection of satellites in orbit. These areas in yellow show the range where the satellites can be seen from the Earth. From here, we can tell that the satellite called BSat should be in range, so we will use that for our demonstration. Next, we will open the Antenna Control applet from the small context menu on the top right of the main navigation screen. Then we will select our target satellite from the combo box and click the Track button. Now we can see the screen begin updating with the current location of our target. Here, we see the SatTrackerPi begin at its default position of due south, azimuth 180, and move to an azimuth of 105. And we will watch as the stepper motors move the antenna to track the orbit of the satellite as it flies northward across our eastern horizon. And so now we can see our polarity begin to update. It's on a 2-second cycle time at 1 degree per second, so every couple of seconds it's actually moving 2 degrees. And we can see our inclination and azimuth are updating to track the target. The SatTrackerPi has its own web interface, which can be viewed with a standard web browser, so you can display the real-time status of your antenna on any computer, even other machines, without the gPredict software installed. Here we will watch the web page update automatically as the antenna responds to commands sent by the gPredict software. The web page gives you some basic control over the position of the antenna, so by itself the SatTrackerPi can move to any heading and elevation specified. However, the Pi does not actually know anything about the position or movements of the satellites themselves. To track a moving object, like a CubeSat, you will need a past prediction program like gPredict. The SatTrackerPi is completely dependent upon the past prediction software for real-time position updates. If the satellite you want to communicate with is moving, then the gPredict software will need to send periodic updates based upon the internal satellite past prediction algorithm. So as the antenna moves, like in our example here, it is responding to individual update commands sent by gPredict or any past prediction software supporting the EasyCom2 protocol. This particular unit was designed to be portable, so it is lightweight and is actually quite small for a radio antenna. As you can see, the transmitting elements and the receiving elements are installed along a single axis, making it necessary to rotate the antenna to find the proper signal polarity. The next unit we build will have 2 different booms, one for the transmitter and a separate boom for the receiver, eliminating the need to rotate the polarity. That setup will make the new antenna significantly larger and heavier. So in our next video, I will show you a preview of that next rotator hardware, and I will discuss in greater detail how the hardware and software work together. So please stay tuned for the next video, and thank you for watching.